Hello, can you hear me?
Hi.
How are you
Hi,
doing?
yeah.
All right, all right. We're here tonight. More people are coming in. So let me show you what I have on my announcement for this week. So just give me 1 minute. Let me put these names in and Maria. Good. So now you can see this is week 6, and the reading we complete chapter 3. Hopefully we begin reading chapter 4. But I think we're gonna finish chapter 3 tonight. And the assignment, you have 3 assignments. The first one is the classwork. I'm going to skip classwork for tonight because I want you to do your test 1 this weekend. So there will not be any classwork tonight. So I limit it to 3 assignments. Complete your homework 3, complete your Excel assignment, and then complete your test 1 by Sunday. Of course, you can access all this from the modules. We go to modules, and let me just, you're already familiar with Alex. So for the test, just I put a practice 1 here. You can see the link for the practice. This is show the kind of question you will see on the test. So I want you to use it to review it, because you're not going to see anything different from all the questions you will see on the test. Will be something similar to this. So you can use it to practice this. And then there's no number 5. That's why you don't see it here. You're going to be around 10 questions or 12 questions. And then you have 2 attempts. Okay? You're going to have 2 attempts for the test. Now, let me show you.
Good evening, Professor. I'm sorry. What did I miss? I'm just logging in.
Yeah, I was just telling them what is due this week. The assignment that you need to complete this week. So there will not be no classwork this week, so that you can just focus on the test. I already created this test 1. So that may probably you know where to get it done, though, right? In the Alex. So it should be showing here. I'm surprised.
Wait, so we're taking the test on Alex.
Test 1 is due this weekend, so it should be here, right here. I forgot to put it. Okay, let me add it there. It's due on Sunday. Test 1. So this is the link right here. When you click on it, it will take you to the test. Okay. Now this is the practice. Use this to practice before you take the test. This is the Excel assignment. Let me click on it. Make sure you're seeing this. Excel assignment means that it will be completed in Excel. So I'm gonna click here. See, so I have a video where I did a sample. Now watch the video first, then complete this. This is the Excel assignment, so it must be done in Excel. When you finish, you upload it for grading. Then next thing I wanted to show you, which is the next assignment that is due this week, is for you to complete your homework 3. So, and that's it. So homework 3, Excel assignment, and test 1. So let's begin the class. So tonight we'll be rounding up data description. And last week I already showed you how to get the quartiles. Let's look at exploratory data analysis. In exploratory data analysis, what we do is we examine the data set to find out if there's any information that we need from the data set. Information such as the center or the spread. And the quickest way to do that is to show you an example. And if you look at this example here, it says that a stockbroker, surprised I didn't remove this. Okay, God. We'll remove all this. I thought I removed all this yesterday. Okay. All right, let's see. Okay. I should have removed all this yesterday, but I thought I did. I can see that I didn't. So I have this removed. Okay. All right, let me remove all this. See. All right. We can begin this. I'm just clearing the place so we can have room. Our work. All these things I put there yesterday. I'm surprised they're still here. Okay, give me 1 minute. Let me take care of all this work. So I'm teaching this class in somewhere under school. So right here. I did all this with them and I forgot to remove it. Okay. Unbelievable. And I was looking for this last night. Okay. Brown, Kelly Brown. All right. I'm letting them all. Yeah, a little delay because I removed all this thing yesterday. I mean, I thought I removed them yesterday, but I can see now that I didn't. Okay, I'm gonna remove all this. Okay. I'm going to remove this. All right. All right. Okay. And let me final check on this. Yeah, final check. All right.
I know I'm a little late, Professor. Just wanted to know what's this for?
Yeah, this is a class we're supposed to have, but I taught this class on Wednesday to a different school, group, and I forgot to clean all this work. So I'm just cleaning it.
Oh, just leave the answers up there. Nothing. I said leave the. I was joking. I said leave the answers up there.
Oh, okay. Oh, well. You need to remove so that, yeah, remove all this. I thought I did, yes, I did last night, but I can see now lower range, upper range, lower range, upper range. All right, let's save this. Okay, this, move this. Okay, so like I said, we started from exploratory data analysis. Okay, yeah. Now, so like I said before, I discovered that I didn't remove some of these things. What we do in exploratory data analysis is to examine the data set to see if there is, to figure out where the center is, or where this, how it is spread out around the mean. So let's use the example to show it. This is how you see the equation in the test 1. This kind of way, I mean, I'm asked to find it 5-number summary. It says a stockbroker is recorded number of clients she saw each day over an 11-day period. And these are the results. On this day, she saw 33 clients, 38 clients the other day, all the way to the last 11th day. You say, identify the 5-number summary and construct a box plot to represent this data set. Okay, so what we do is we will find it's a 5-number summary. So that means we need to get, first of all, get the Q1, Q2, and Q3. And I showed you from last week how to get it. Now, there are how many numbers? How many days? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our N is 11. And for Q1, like I explained last week, Q1 is the first quartile. And the first quartile, if you still remember, is the first 25%. That is, it's the same as the 25th percentile. So our P will be 25. So going down there, our P will be 25. You can see 25 right here. So let's find the first quartile. Now, that means our Q1 becomes, and see the formula N times P over 100. N is 11 times P of 25, okay, divided by 100. So we put it on our calculator. 11 times 25 divided by 100. So we got 11 times 25 times 25 divided by 100. And that gives us 2.75. 2.75, which is the, and like I explained last week, when you have a decimal, go to the next number. We have a decimal, go to the next number. Let me get this person in. Okay. So it's a 2.75. What is it again? Yeah, 2.75. So I'll go there and put 2.75. 2.75, which means if you have a decimal part, go to the next number, which is the third number. So now, the third number from the list. Oh, I forgot to mention, you must put the list in order first. You must arrange it in order from the smallest to the largest, and then it is arranged here. Consider the smallest here and see the largest here.
I'm sorry. Hello, Professor. I'm sorry. So what's the Q1? I know you were saying, talking about that.
Q1 is the first quartile.
The first quartile. Okay. So which one is the first quartile?
Huh?
How do you find the Q1? How do you find the first?
That's what I'm doing now.
Okay.
So you put them in order and you plug them into the formula. N is 11 numbers, P is 25. Put them in. We just
I see that. I'm saying, like, how did you get the equal 1/3 number? What's the?
Yeah, because I said when you have a decimal like this, go to the next number. So that is the third number.
Oh, okay.
And then you go to the list. Count 1, 2, 29 is the third number. It's 29. So now we have to get it.
But how did you get 25 for P?
Huh?
How did you get 25?
Okay.
It's
like a quarter. From last week, I remember I explained that the quartiles, we did quartile last week, and I explained that the first quartile is 25, the same as 25 percentile. So
okay.
I explained that last week. Let me copy this and move it down so it will be easy for us to refer to it.
I understand. So because you said the quartile was the first 25%, so that would make
for the first quartile.
Okay.
Second quartile is the 50, is the same as the median, which is the same as the 50th percentile. So for the one we're about to calculate now, which is the second quartile, our P will remember the number is still 11. There are 11 numbers in the data set. And then for the second quarter, our P is 50. So now we can now calculate it using the same formula, N times P over 100. And that gives us, we got, so our Q2 equals, our N is 11 times 2050 this time over 100. 11 times 50 over 100. So we have, we go to our calculator and put it in, change this to 50. And it was 5.5, 5.5. So 5.5, which is the sixth number. Okay. Now we go to our list and count this, get the sixth number. The sixth number is, say, 1, 2, 3, 4, 5, 6. So remember, don't forget, you must arrange the data set into put it in an ascending order. That means arrange it from the smallest to the largest before you start calculating the quartiles. If you don't arrange it, the answer will be wrong. You might pick the wrong number. So you make sure you arrange it from the smallest to the largest first. Okay. So our sixth number becomes 1, 2, 3, 4, 5, 6, which is 33. 33. Now we have found the third quartile. Then the fourth, we have found the second quartile. The third quartile now becomes, remember, our N is still 11 because we have 11 numbers in the list. So I'm going to put right here. But this time our P will change. For the third quartile, is the sum of the 75 percentile. So our P this time will be 75. So I'm going to put 75 here. So that Q3 becomes equals 11 times 75, okay, divided by 100. So we go to our calculator, 11 times 75, go there and then change this to 75, okay, like 8.25, 8.25, okay. We go and put 8.25 here, 8.25. You know, in algebra, if they say to round off this, that means it's gonna be 8 number. But here we're not doing that. So long as you have a decimal part, go to the next number. So we look at 9th number here. And 9th number here on the list. Go to the list, have 1, 2, 3, 4, 5, 6, 7, 8, 9, 42. 9th number is 42. So with this, we can now answer the question. The question says, find a 5-number summary and construct it. Let's find the 5-number summary now that we have the quartiles. The smallest number here is 23. The largest is 51. So I'm going to put have the minimum number, that's smallest is 23, and maximum is largest number there in the list is 51. Okay, 51. So I'm going to put 51 right here. 51. Then the first quartile, our Q1, first quartile, it's a Q1. Q1 equals our Q1 was 29, and our Q2 is our Q2, we found it to be 33. Then Q3 will be 42. Okay, 42. Now, when you count them, you see 1, 2, 3, 4, 5. That is your 5 number summary right there.
Hey, Professor. So this gonna be part of the test too. This that you're showing us now or no?
Yeah, I should, yeah. I showed that you guys what you need to review for the test. See, I
Oh,
attached
so
it
that's
here.
and this is the what we're doing right now.
Yeah,
Cause I want to know what they even on the test would they like provide us with like P?
no,
Like,
no, you have to figure it out by yourself. That's why I'm teaching it now.
but you
And
didn't show us how to find the P. You only show us how to find the Q1.
say it again.
You haven't shown us how to find the P. You only shown us how to find the Q1. The
I
P is
showed you. I
already
showed you
given.
how to find the P. Right, just hold on a minute. I showed
Okay.
it right here. See? Can you see that? And I told you that the P for Q1 P is 25, and I told you that for Q2 P is 50, and I told you that for Q3 P is 75. So I did. I showed you how to find it. Now, this is a 5 number summary. And that's why that question asked to find the 5 number summary, and that is it right there. And then I'm gonna just put insert here to and put the these are the 5 number summary right there. Because that 1, 2, 3, 4, 5 numbers. Now we answered one part. The second part says to construct a box plot to present this data. To construct a box plot to represent this data. Now, to draw the box plot, we know that the smallest number here is 23 and largest is 51. So using that information, we can draw our box plot. We have, I'm going to start from, this is the smallest is 23, largest is 51. So I can start from 50, from 20. So I got 20, 25. I can even make it 3 times. Now, use your own scale. 25, 30, 35, 40, 45, 50, 55. I stopped at 55 because, as you can see from here, maximum number is 51. So I can even make it 4, distance 4, so I can put my the drawing to make it more clear. Okay. And this one. So I can just put my line there now. Yeah, I can put my line. So I can draw the box plots. Now, our Q1 is 29 and our Q2 is 33 and Q3 is 42. So I can put the box from here. Q1 is 29. So 29 is gonna be somewhere, this is 25. So 29 is gonna be somewhere here. Okay, let's start 29 right there. 29. Okay, 29. And then Q2 on our list. Q2 is 33. So it's gonna be 33. This is 35. 33 should be around here. So 33. Okay. So you're gonna be, let me draw it. So you can see where it will be on the box. So in exam, they will just we will giving they will show you where to type the numbers. You can just type the numbers and it will draw it for you. Then Q3 is 42. This is 40. 42 should be around here. So I'm gonna move it 42. Should be around here. Then the whiskers minimum is 23. 23 should be somewhere here. Okay. 23 should be somewhere here because 23. That's it right here. And then next one is 42. I just follow it. Actually 51, not 51 is the maximum. So 50 will be here, 51. Then of course you put the whiskers. Yeah. So the whisker goes right to that number and to that number. So that's the box plot. And you can see that from the box plot that this side is bigger. So we say that the data set is skewed to the right because the right side is bigger. We say that it is skewed to the right. Yeah. And this is your 5-number summary, and this is your box plot. Any question on this? Okay.
Are you going? I was going to ask, were you going to show how to do this on Excel as well?
Oh yeah. I'm about to do that now. So let me since there's no since that is the only question, let me do it on Excel so you can see it. Okay. Let me get the question says the stockbroker recorded number of clients she saw each day over an 11-day period. The data are shown here. So I say identify the 5-number summary and construct the box plot to present the data. So let me, to do it in Excel, the first thing you need to do is to type the numbers inside Excel. So let me write them down so I can type them in, and you can get it from Excel. And when you're taking your exam, you can use Excel to solve it, and just solve it on Excel and type the answer in. Since you're doing the thing in Alex. So I got 33, 38, 43, and next one is 30. Okay, 30 here, 30. Okay, this one is 29. Okay, 40. Okay, 51. We got 27. We got 42. I got 23. Okay, and we got 31. This is Sean. X. Okay, make it in. So now I have them in. I have the numbers 33, 38, 43, 30, 29, 40, 51, 27, 42, and 3, 31. So let's go and put it in Excel. I've already opened an Excel page, so we're gonna type them in. 33. I'll make this thing bigger. Yeah, make it bigger. Okay. 33. Make sure you're seeing this. Yep, 33. So I got 38. 43. 30. 29. 40. 51. 27. 42. 23. 31. Okay. So the question says to identify the 5-number summary and then construct a box plot. Okay. Identify 5-number summary and construct a box plot. So let's just go and do it in Excel. We need to find the minimum value. Minimum. To find the maximum. To find the Q1 first quartile. It is Q1. Okay, second quartile. It is the Q2. Then third quartile. Q3. So you have all this. So now, like I showed last week, you can get Excel by just using a simple Excel command, it will give you the result right away. For the maximum, we can just do equal max. For the minimum, I mean to say min, MIN, and it will pop out here, double click, highlight all this, and then press the enter key, giving the max minimum. And you can see that it is the same minimum that we have here. You can see that it's 723. Okay. Now for the maximum, you have equal max. It pops out, double click. Okay. All right, then press the enter key. Okay, that's 51. And you can see that it is the same 51 we have here. 51. All right. Then next will be Q1, type equals. Then type quartile. And this use quartile.exe. You can see that it wrote here, returns the quartile of the data set. Okay. Double click on that. Highlight all, comma, then type 1. 1 is for first quartile. You can see right here, first quartile is 1. And you can see that it is the same as the 25th percentile. Press the enter key. 29. And when you look at what we had before, you discover that it is 29. Okay. So I've shown you a lot. So let's just complete it. Second quartile equals quartile .exe, highlight this, put comma, put 2. 2 is for second quarter. You can see right here. You can see 2. And they can see that it is the 50th percentile. Okay, press the enter key. 33, which is the same as the 33 we have here. Okay. I forgot to put the fourth quartile, which is 42 right here, 42. 42. Now, next will be the third quartile equals, okay, quartile, okay, .exe, then highlight all this, comma, then for fourth quartile is third quartile is 3, so put 3 there and press the enter key. 42. Now this is your 5-number summary right there. This is 5-number summary. See? So there are 5-number summary because there are 5 of them. 1, 2, 3, 4, 5. Now you say construct the box plot. But Excel does the box plot in a different way, a little bit different way. Let's see. Let me move this down so you can see this top. Now we can do that by highlighting this, clicking on insert. Now look for the box plot. Look for in one of these places. It's gonna be. Let me see if it's here. Yep, I have it. So you can see where you have box and whisker. Box and whisker. Click on that. See? You give us the same box plot. The same thing that we have over here, but you put it in a vertical position. Like you turn it in a vertical position. Vertical. See? Like you have it drew the box plot to be like something like this. You see? Then you know. Otherwise, it's the same thing. You can see right here. Now, I can put here title as the box plot. Plot for stockbroker data. Stockbroker data. Okay. Now I can give to the good news about this box plot is that when you draw it in Excel, you don't have to start see. Remember how we calculated all this, okay? But first smallest one, largest one, Q1, Q2. But if you draw the box plot, if you just highlight the data and draw the box plot, when you label the box plot, click on the box plot, okay? There, right click on it, right click, See, add data labels. See, it will put numbers by themselves. See, they're all in. You can see the 33 here. You can see the 29, 42, 51, and 23, which is the same thing that you found here.
Professor, can you show me how you did that one more time? I'm sorry.
You mean the box plot?
No, how you just got those numbers to pop up.
Oh, okay. Just give me 1 minute. You can see that it is the same numbers that we have here. Okay, now to answer your question, let me undo it. Select, just click on the box plot, then right click, then click on add data labels. They'll all be in. Okay, and I can see all those numbers are in. So now, and then I can now remove this. Now, if you're doing this as a project, you can click at the line, then copy it, Ctrl C, and then go to your project where you're typing your project, and then paste it there. You can paste it under the project right here. Let's say I pasted it here. I can paste it here, right? Can see the same number we have. Oh, okay, you can see it. Okay, good, excellent. You can see the same number we have. 33. You can see 33 right there.
Hey, will you say you clicked on what? I'm sorry.
Say it again.
Yeah, can you repeat that? You clicked on to post it?
No, what do you want me to click on?
No, how to get it, to move it. I
How to
forgot.
move it to Word? How to
On
move it?
Excel, on Excel, how did you copy and paste it?
Oh, okay. Let me do it again then.
Sorry. I don't know.
No problem. Let's see. Let's go back here. Now, I wanted to copy it and put it in a Word, right? I go to this line. See my hand?
Yes, sir.
Just click there, just once. Then do Ctrl C, and then
Oh, okay.
then go to the Word document where you are doing a project, and then Ctrl V.
Oh, that's how I did the last time, but I didn't know it was something else we did different.
Yeah, so that's it. And then you have your, so you can see that you just put it in a vertical position, unlike here, I did it in a horizontal position, but it's still the same thing.
Okay, so when you did it horizontally, you put that the data was skewed to the right. So what do you put when it's vertical?
It's the same thing. See, this is the right side.
Okay, so you still say that?
Yeah, if you turn it clockwise, you can see this is the right side, this is the left side. This is the smallest number, this is the largest number. So this is the left side, this is the right side. So it's still right skewed. Now, you can try this for your practice. You can use the practice. Let's go to the next thing we need to, so that we can round up this chapter. Empirical rule, and then Chebyshev theorem. Empirical rule and the Chebyshev theorem. Now, in the empirical rule, state that for data sets having a distribution that is approximately bell-shaped, or that is normal or symmetric, then that distribution have these properties. About 68% of all values fall within one standard deviation of the mean. About 95% of all values fall within two standard deviation of the mean. And about 99% of them, 99.7% fall within 3 standard deviations of the mean. Now, let me explain this with a chart. You can see the chart right here. Now you can see the number. This is the mean. Okay. Now this is from here to here. You can see 34%, 34%. So we have from our calculator 34 plus 34 give us 68%. And that is what it is saying. And when you look at that section, you can see that both of this is negative 1 standard deviation. This is positive 1 standard deviation. And this thing fall within this 1 standard deviation and 1. So the negative sign is just to tell you that it's on the left side, that's all. And the positive to say that it is on the right side. And but both of them are 1 standard deviation. You can see 1 right here and 1 here. And when you add them, you get 68%. And that is what this first sentence say, that about 68% of all values fall within one standard deviation of the mean. Now, for the second one, it says about 95%. If you add all this, starting from here all the way to here, which is 13.5% plus 34% plus 34% plus 34%. So let's go and add them. You can see that you have 13.5, 13.5. Oh, excuse me, sorry. 13.5 plus 34 plus 34 plus 13.5, which is 95. So, and when we look at that, you can see that they fall within 2 standard deviation on both sides. And that is what this statement is saying, that about 95% of them fall within 2 standard deviation of the mean. So, and if you do that for 3 standard deviation of the mean, if you add all this, starting from the negative 3 standard deviation to positive 3 standard deviation, you can see that they will add to 99.7%. Now, we use the empirical rule for only distribution that are symmetric. Either they might say that it is normal, or that they say that it is symmetric, or they say that it is bell-shaped. They must mention it on the equation. That is how you know that this is, I'm going to solve this using empirical rule. These numbers are set on stone. You can't change them because they say they are symmetric. Now, and to solve problem for using empirical rule, you have to find the answers for all these formulas here. If you look at all the left side, they are subtracting the standard deviation. Here, they subtracted 1 standard deviation. Here, they subtracted 2 standard deviation. Here, they subtracted 3 standard deviation from the mean. On the right side, they add the standard deviation. You can see that they added 1 standard deviation here, and they added 2 standard deviations here, and they added 3 standard deviations here. But in general, in life, data set that lies within, if you look at this statement that I made here, I say unusual. Data entries that lies more than 2 standard deviation of the mean are considered unusual. That means they're not normal. While those that lie more than 3 standard deviation of the mean are very unusual. Let me explain with example. See, it's saying here that these numbers here, that any data set that falls within 2 standard deviation on the left side and 2 standard deviation on the right side, they are the usual. Let me make this bigger. They are considered the usual values. Okay, it's too big. Let me make it 14 then. Okay, 12 then. 12 should be good enough. Okay, good. Now, why usual? Let me make this usual. Make it bigger. I can move this back. Okay. Why? Okay, now, for example, there's what we consider to be normal blood pressure of a human being. If it falls within this group, or normal blood sugar level. Anything that is considered normal range, usual. But abnormal range, for example, here you have, give me 1 minute, let me check this person's name. Okay. You have I'll give you 2 examples with usual range with a blood sugar. How about this? Let's say in Maryland, the salary for public school teachers maybe from $60,000 a year, maybe to $75,000 a year. That is normal or usual range of salary for public school teachers. Now, if somebody tells that a teacher in public school is being paid in Maryland is being paid $120,000 a year, that is not the normal range. And at least for 2024, that is unusual. See? So usual range is normal range is what that range that is considered normal, good. So now, but if it is unusual, anything that is bigger than that normal 2 standard deviation, we would say that it is unusual. Like here, you can see this place that this is unusual on the left side. This one is unusual for 3 standard deviation is unusual. Yeah, see, make it bigger a little bit. It's unusual, right? And on the right side, for 3 standard deviation is also considered to be unusual as well. And I'll give you an example. I have given you an example with a teacher in Maryland that is making $120,000. That's unusual. It's very rare. I mean, principals can make that, but not teachers. But if the principals can make 100,000 to 120, if there's a principal in Maryland that is being paid 300,000, that is unusual. You see? So now, so any data set that fall within 2 standard deviation is usual, is normal, considered normal. But above that, on the left side or on the right side, is considered unusual. So, and the formula, in general, we use the following equation for empirical rule: mean plus or minus k standard deviation, where this k represents the number of standard deviations. Okay. So on the left side, we have k, mean minus k times standard deviation. And on the right side, we have mean plus k times standard deviation. And you can see it from here. Left side is my mean minus 1 standard. This 1 represents k. These 2 here represent k. And this 3 k on the right side. So on the left side, we are subtracting. And on the right side, we are adding. So now, if you are given a question that involves empirical rule, you have to, for most of them, you have to figure out the answers for this. Then you can now answer the question. Now let's look at, before we solve an example with empirical, let's look at Chebyshev theorem. According to Chebyshev, the position of any data set lying within k standard deviations of the mean is at least 1 minus 1 over k squared times 100%, where k represents the number of standard deviation from the mean. Now, to use this one, empirical rule can only be used for distribution that have this shape. So in questions that involve empirical rule, you'll be told that assume that the data set is normal, or they will say assume that the data set is barrel shaped, or they will say that assume that the data set is symmetric. Then you know that you're going to use it. But if you didn't say that, that means you can't use empirical rule. You use Chebyshev. You can use Chebyshev for any distribution. So, and the Chebyshev says that at least 75% of data entries fall within 2 standard deviation of the mean, and then at least 89% fall within 3 standard deviations of the mean, and 94% falls within 4 standard deviation of the mean. Now, for Chebyshev, there are 2 formulas we use. Either this one to estimate the percentage, and we can use this one to find the value of k. K can be found by using upper end minus mean divided by standard deviation, or you can use this lower end minus mean divided by standard deviation. Okay, let's solve an example. Maybe 2 examples on the empirical rule, and probably 1 example on Chebyshev. Says here, past result. Excuse me. Wait, water. Yeah. It says past results from the National Health Survey suggests that the pulse rate, which is the heartbeat per minute, of women have a mean of 76 and the standard deviation of 12.5. Assume that the distribution is symmetric. Find the minimum and the maximum usual rate. See? You can see that here, it says here, assume that the distribution is symmetric. That will tell you that you're going to use empirical rule. It says find the minimum and maximum usual rate of women, and then determine whether a pulse rate of 110 should be considered unusual. So we are told that the mean is 76 and that the standard deviation is 12.5. You can see I wrote them here. Now, remember I mentioned that the usual rate is when it falls within 2 standard deviation. That means we're going to be using mean minus 2 standard deviation for the left side and mean plus 2 standard deviation for the right side. That is the one that is considered usual. So I wrote them down here. For the minimum rate, we have mean minus 2 standard deviation. That means mean is 76. Oh, excuse me, 76 minus 2 times, okay, 2 times standard deviation of 12.5. Okay, let me write this down so we can get it from the calculator. We got 76 minus 2 times 12.5. So that will give us, let's go and get it from the calculator. We have,
Hello.
yep.
I'm sorry. I don't want to keep in this one, but I am gonna meet this one because I don't understand nothing you're talking about. I don't understand how you got any of that. I just don't understand. It's very confusing. Extremely confusing.
I will save I'll record this video so maybe you can watch it again. So this question we are trying to find out. They tell us that the mean range for pulse rate for women is 76 and that the standard deviation is 12.5. So they said they asked to find the minimum and maximum usual rate, pulse rate for women. And a few minutes ago, I explained to you that the usual range is considered the one that fall within 2 standard deviation on the left side and the right side. So we're going to use these 2 formulas, this one here and this one, to find the minimum and maximum. So that's what I'm doing on this section.
How did you get it to use those to the negative 2Q and the positive 2Q?
No, it's not Q, it's standard deviation. This
Okay, standard deviation. I'm sorry.
Yeah.
It looked like Q. I don't know. I'm confused. Please.
This one is the formula that we use for this bear curve. So I mentioned a few minutes ago that this can you see this what I wrote here?
Yes.
That is usual, right? So that's how I get it. That's from 2 mean minus 2 times standard deviation is fall within the usual range. And mean on the right side. On the left side, they use minus, on the right side, they use plus. So mean plus. So that's how I know that this one and this one are the usual range. Because I wrote here and I use a chart to show you that this is the range for usual. So that's how I got this and that. So I put on this bear curve. This is not set in stone. So it cannot be changed. So these formulas are there for you to use. So given that explanation, you can say that it says assume that the distribution is symmetric. That's how you know that you're gonna use empirical rule. Then you know how we get the mean. It is given here, and the standard deviation is given here as well. I wrote them down. And for the usual range, we say that it's gonna be 2 standard deviation from the left side and plus 2 standard deviation on the right side. So I'm just putting them in. I'm just putting the numbers I found inside the formula. So you have 76. Maybe after you watch the video the second time, you might understand it. 76 minus 2 times 12.5 gives you 51. So we have 51 right there. 51. Then you do the same thing, but this time around you use plus. So I'm gonna just copy this and change this to plus. Okay. I got 76 plus 2 times 12.5. So I'm going to the calculator and put plus, change it to plus. Make it plus right here. 101. Okay, this is 101. 101. So this is 51 bits per minute. And this one 101 bits per minute. So that answer part A says find the minimum and maximum usual pulse rate for women. So the maximum and minimum is the pulse rate for women is between 51 bits per minute to 101 bits per minute. And then they ask you Determine whether a pulse rate of 110 will be considered unusual. Well, 110 beats per minute does not fall in this group. It falls outside this interval. See? So it is unusual. That's why I wrote here that a pulse rate of 110 beats per minute is unusual because it falls outside the usual range. Does anybody have a question? Please ask. Okay. Now let's look at another example. It says here that the mean speed of a sample of vehicles along a stretch of highway is 57 miles per hour with a standard deviation of 4 miles per hour. And he wrote here, assume that the data set is bell-shaped. See? Assume that it is bell-shaped. And it says here, estimate the percent of vehicles whose speeds are between 63 miles per hour and 71 miles per hour. Then it says, suppose the number of vehicles in the sample is 75. Estimate number of vehicles whose speed are between 63 miles per hour and 71 miles per hour. Then it says, it also says here, in a sample of 25 additional vehicles, about how many vehicles will you expect to have the speed exceeding 71 miles per hour? So how do we do this? First of all, we are given that we are told that the mean is 67 miles per hour. So I have it here written, mean 67 miles per hour. And they also say that the standard deviation is 4 miles per hour. I have it here. Then they added that assume that the data set has bell-shaped distribution. So that means I'm going to use this formula here, which means that I need this chart. Okay. Now, to be able to use this chart to answer that question, we need to get the answer for all this. Okay. For example, the first one will be, we are told that the mean is 67. So our answer here, this is the mean right here. So we're going to write 67 here for the mean. See, that is what this symbol represents. So to get the answer for this one, we're going to do 67, 67, okay, minus 1 times delta, which is standard deviation, which is 4. Okay. Okay, that will give us the answer we put there. 4. See? So that will give us as you go to the calculator, have 67. I think I'm gonna write it down so I can see it while putting it on the calculator. So I got 67 minus 1 times 4. Okay. 67 minus 1 times 4. I got 67. 67 minus 1 times 4. 63. Okay, I got 63. So our answer for this one, we're gonna be 63. So instead, just keep subtracting 4 from each of them. Keep subtracting the standard deviation. If you subtract 4 from 63, you're gonna get the answer for this one. So 63 minus 4 are gonna be 59. 59. See? And 59 minus 4 will give us 55. Now, so on the left side, you're subtracting the standard deviation. Then on the right side, you can see that it is plus. Keep adding the standard deviation. We have 67 plus 4 will give us 71. And then 71 plus 4 will give us 75. and 75 plus 4 will give us 79. So on the left side, you subtract the standard deviation, which is 4. And on the right side, you add the standard deviation, which is also 4. So now you got the answer for all these formulas here. So look at the answer for all these formulas. Now, once you got it, you will be able to answer these questions, Part B, and Part C. So to make sure that you have the answers correct. Now let's answer Part A. Part A says, estimate the percent of vehicles whose speed are between 63 miles per hour and 71 miles per hour. No, you can see the 63 right here, and you can see the 71 right there. See? 63 from here to 71, right? I think that's what they said. 63 miles to 71 miles. Okay, good. You can see right here. Right here, 34, see? So that you can see the percent here, 34% and 34% from here to there. See? I can see my drawing to show that. So that the percent of vehicles whose speed is between 63 miles per hour and 71 miles per hour is on this side, you can see that it is 34%. From 63 to 71, you can see that 34. So you have 34% plus 34%. That gives us 68%. So you answered it. So that the percent of vehicles whose speed are between 63 miles and 71 miles is 68%. And you can see from the screen here, you have the 63 to 71, and you can see that it is from here to here. Okay. The answer Part A. Now, Part B says, suppose that the number of vehicles in the sample is 75. Estimate the number of vehicles whose speed are between 63 miles per hour and 71 miles per hour. So we have it here already, from 63 to 71, and we have our answer as 68%. Now they're asking you to suppose that there are 75 vehicles in the sample, and they want you to estimate how many of them have the speed of 63 miles an hour to 71 miles per hour. So all you need to do is to use the percent to multiply the n. And they said that how many vehicles, which is 75 of them, you have n is 75. So that means the number of vehicles whose speed are between 63 miles per hour and 71 miles per hour becomes, we have the percent already, it becomes 68% times 75. And that gives us 68%. When you change it to decimal, I see 68% change to decimal, it'll be 68 divided by 100. 0.68. Okay. So you go there and put 0.68, 0.68 times 75. Okay. So we have it here as 0.68 times 75. Yeah, 0.68 times 75 vehicles is 51 vehicles. 51 vehicles approximately, right? 0.6 times 75, yeah? It's 51 vehicles. So I'm going to take it here. 51 vehicle. Okay. Now, that answer Part B. Then Part C says, in a sample of 25 vehicles, how many vehicles will you expect to have speed exceeding 71 miles per hour? Now look at here. This is why you have 71 miles per hour. You can see right here. And they say how many vehicles do you have? Say in a sample of 25 vehicles. So our n here becomes 25. Put it down a little bit. 25. And they want you to find the percent of vehicles whose speed exceeds 71 miles per hour. Now look at, if you look at the chart, you can see 71 right here. Above it is this one. See? So that means they're talking about from here, excuse me, from here all the way to the end. And the percent that we found there from this point is 13.5% and 2.35%. So we have so that the percent to be 13.5% plus the other one that exceeded is right here, 2.35%. 2.35%. So that will give us, let me write this down so we can get it from the calculator. 13.5% plus 2.35%. We have 13.5% gonna be 13.5 plus 2.35. 15.85. I got 15.85%. 15.85%. Okay. So we have it as 15.85%. Now, once you have this percent, now you can now be you will not be able to answer this question. The question says, in a sample of 25 vehicles, about how many vehicles would you expect to have speed exceeding 71%? So again, this is the section that exceeds 71%. And the 2% we added are 13.5% plus 2.35%. We added them to get 15.85%. So the number of vehicles we're looking at says would be number of vehicles, okay, of vehicles with speed exceeding 71 miles per hour equals you're gonna put this as 15.85% times the number of vehicles we are giving. We are giving as that n is 25. And that would be, you change this to decimal, you're gonna give you 0.1585 times 25. So let me write this. Yep, let's go and get it from the calculator. I think I can get it from the calculator. So you have, write it down here, 0.1585, 0.1585 times 25 vehicles. 3.963, 3.963, which is approximately 4 vehicles. 4 vehicles will have speeds that exceed 71 miles per hour. If you have a question, ask me, I will explain. Okay. All right, then. Now, at this point, let's look at another example. This will be our last example for tonight. It says, the average check at a local restaurant is $36.42 with a standard deviation of $8.15. What is the minimum percentage of checks between $15.25 and $57.61? Now, you notice that in this question, it didn't mention assume that it is symmetric, like here. The one we just solved, they mentioned that they say assume that the data set has bell-shaped distribution. And the other one we solved, they say the same thing. I mean, something similar. Assume that the distribution is symmetric. But in this case here, they didn't say it. They didn't say anything. They just gave us the information. So that means you cannot use empirical rule. You can solve this. You can only use the Chebyshev formula. Okay. So again, let's read the question. The question says the average check at a local restaurant is $36.42 with a standard deviation of $8.15. What is the usual minimum percentage of check between $15.25 and $57.61? Now, we have the mean as $36.42 and the standard deviation as $8.15. So first of all, we need to find find our K. So we need to find once we find the K, we will be able to answer the question. Say what is the minimum percentage of check that will be between $15.25 and $57.61. Now remember that Chebyshev. Let me refresh your memory with what Chebyshev theorem says. It says here that the position of any data set lying within K standard deviation of the mean is at least 1 minus 1 over K squared times 100%. So we're trying to answer the question we're about to solve. We need to find our K first. And to find K, let's find it using the two formulas given. You can only use one of them. Either you use this one, or you can decide to use this one. I will show you that both of them works. So if you look at the question, say what is the minimum percentage of checks between $15.25 and $57.61? So the lower side, you can say that it's $15.25, and the upper side is $57.61. So let's find out K. We are already given the mean as $36.42 and the standard deviation as $8.15. So let's plug it to, let's find the K using the upper end. So in that case, K equals our upper end is $57.61. It is 57.61 minus 36.42 divided by the standard deviation of $8.15. Okay. Let me write this down and then we can get it from the calculator. I got $57.61 minus $36.42 over $8.15. Let's go and get it from the calculator. Okay, we have $57.61 minus $36.42 divided by $8.15. We have 2.6 here. So we go and put 2.6 here. So our K is 2.6. Now, as a check, you can use this using the lower end where you use the 15. Oh, you know, I have upper here. This should be lower here, not upper. Lower. And this one should be upper end, upper right here. Yeah, I gotta save this. Is the problem now? So now we can have this. I mean, this is what our K is, but as a check, we can use the lower end, which is $15.25. So if we try that, we can have this. Okay, equals $15.25 minus $36.42. Okay, divided by standard deviation of 8.15. So let's go and put this in the calculator. I'm gonna write it down. $15.25 minus $36.42 divided by 8.15. So let's go there and then put it in. So I can just change this to $15.25. I got negative 2.598. Let me write it down. Negative 2.598 rounded. So I can go and put it right there. So negative 2.598, which is approximately negative 2.6. See? So you can see that it's the same thing as we have at the above, except that this one is negative. Negative means that it's on the left side, that's all. So you can see that those both formulas work. Now we have our K. Since we have our K, we can now be able to answer the question. It says, what is the minimum percentage of checks between $15.25 and $57.81? So to solve that, answer that question, we're going to use this formula here. Have 1 minus 1 over K squared times 100. Okay, so I'm going to put this formula. We have our K already as negative 2.6. So I'm going to put this formula in our workbook where we can get it the right way. I'm going to insert an equation. And okay, so to have it, enter it here. See, minimum percentage, right? Because the question was the minimum percentage of the minimum find the minimum percentage of checks between $15.25 and $57.01. So I'm gonna use the minimum percentage equals that minimum percentage. Okay, minimum percentage. Percentage equal. I make it big a little bit. Yep, make it a little bit bigger. 14 should be good enough. So that means we have our K as 2.6. So we're gonna be equals the equation. I will have this here. We got 1 minus 1 over 2.6 squared. Because let's say K squared, that means 2.6 squared. Okay, squared. Okay, times it times 100. So I have times 100 equal. Now let me write this down so I can put it in a calculator. 1 minus 1 over 2.6 squared times 100 equal. So let me go and put this in a calculator so I can get our answer. So I got 1 minus 1 over 2.6 squared. 1 over 2.6 squared. Okay. Was it times 100? 85.2%. See? 85.2%. 85.2%. So I'm gonna copy this. It let's bold. Okay. Then copy this and paste it in our main workbook. So we have answered that question of minimum percentage. So that the minimum percentage of checks between $15.25 and $57.81 is 85.2%. Any question? Okay, no question. Good. So now, like I said, I will not keep you long tonight, so because I want you to make sure that you did your test. Remember, this is the practice. I put this thing here so that you can use it as a kind of a study guide for your test 1, which must be done completed this Sunday. You can see practice on these questions here. These are the kind of questions you will see on the test. Okay. Now Next thing I want to show you is for those of you what is it? What is it? What is it? What is it? Okay, let's see. Yeah, this is it right here. All right, let's see. Okay. All right. Now, again, you can see that this is to let's give you. I'm not giving you a class, no classwork this night, so that you can focus on the test and the Excel assignments. So this is your finish your homework for the week. Homework 3. Do your Excel assignments. Take your tests, and I will see you guys next week. When we come back next week, we start working on the theory of probability. Now, before we leave, any question before we leave?
I don't understand nothing.
I know you can. I will recommend watch the video again. I will put the video. Watch it over. Maybe by the time you watch it the 3rd time, you understand it. Okay.
Are you posting it right after you end the session, or when are you going to be posting this video?
I'll post it after the class. Yes, the same place I normally post it in the announcement.
Okay.
Watch it over and over. Okay.
Okay.
Mm.
Lord.
Okay,
Yeah.
now a
It's
quick
kicking my
question.
butt. I
How
said
will we-
this course, this semester, I don't know, maybe this is not my semester.
No.
But this class
Let
is
me tell you
kicking my
something.
butt. This is
Let me
so
tell you
confusing.
something. In maths, sometimes one topic might be hard, the next one might be easier. You know what I mean? So
Yeah, the beginning was easier than after we started getting, I'm like, what the heck? Not like math, but I'm so lost. Like,
no, see, now I want you to do this as an experiment. So maybe next class you will tell me what you find out. The place you mentioned that you don't understand is actually the empirical rule and the Chebyshev, right?
mhm.
Yeah, good. Watch that part 3 times or 4, make it 5 times, okay? And then try this one here by yourself. Let me see if I can put what is it? What, so let me hold on, let me pull it up. I think I closed it by mistake. Yeah, I think this is it right here. Then try yeah, try what interval okay. Try the one I will just give you the one that we did. Don't do the ones that we didn't do, because I will not be asking you this type. Try an example in your textbook that looks like this, or that looks like this one, or even this one. So I can even try it as you are watching the video. You can even be doing this same question as you are watching the video.
Okay.
If you try like 5 times, I think it will register.
Yes, sir.
Mm-hmm.
I was going to ask, well, in this test, will it describe what formulas we're supposed to use?
You can use the formula in the textbook if you want, but I recommend that you use the one we are using. Like if you scroll all the way down this handout, you will see all the formulas we have been using. See, all of them are at the end of this handout.
Okay.
So, yep.
Professor, so we're going to get this copy that you're showing us right now. We're going to be able to get this so we can feed from that.
You mean the video or the handout?
Oh, okay.
Handout.
I was talking about the paper, what you're showing us right now, showing us where all the
Oh yeah, I can upload it. Yes, of course.
Okay.
Matter of fact, let me upload it now so that you can see where it is. I can show you where it is located. Okay.
Because I think that's one of my issues I'm having, is knowing which formula goes with which problem when they're asking, because all of them sound the same.
Well, actually, they don't. But give me 1 minute. Let me upload this, and I'll. Okay. This is the.
So we don't have classwork today, right?
No. I would just want you to focus on the test and the homework that is left.
So just making sure, are you going to move back the date? Because if you don't move it back, it's just going to automatically give everybody a
Oh, no. When I grade it, I will put the correct. Oh, I don't understand. Ask your question again.
Because it's due tonight, and if we don't do it, Canvas automatically grades it as a 0.
Oh, I will grade when I grade it will change back to what it is, what it should be. Okay.
Okay.
So
what,
maybe let me see. Let me get this thing done. Let me show you. I think let me show you where this turned out to be when I think I uploaded it now. Let me put it. So you're gonna be where this is. Okay. Let me see right here. The file.
All right.
Oh, this is fine. And there. This is the latest thing I put there. Up right here. Okay. So it should be right here now. Now, for the person that says, if I ask you to find them in the test, right?
Professor, I had a quick question. So I think somebody just asked you this, but I think you probably had already did this ahead of time. But it's saying tonight that we in our modules, it's showing us a classwork that's supposed to be for tonight, but you said you didn't, you're not giving us one. But I think that's what she was talking about. It's showing that it is one, but you
right.
don't see anything there. I think that's what she was meaning.
Okay, let's see. Class for 5. This one is already. This one is okay. This one.
Number 6.
You're talking about
Classwork
6, right?
Yes.
Yeah.
Let me just
Switch that date.
let me remove the due date from it because there's no
Yes.
classwork.
It makes us feel better when that 0 is not there because our grades look better. We already.
I think I fixed the problem now.
It makes us anxious. So if you give us a good grade, we'll at least have a B. But if it says 0, it's going to take it down to a C.
Yeah, I think I fixed the problem now, so it won't be it won't be telling you any dates anymore. So let me see. Yeah, we are there now. See, I removed the dates. So
Thank you so much for
no
not
need to
giving
worry
us
about it then, yeah.
classwork. Thank you so much, because
Of course.
that's we got a lot of work.
Yes,
after
thank
this.
you. Thank you. Thank you.
Yeah, sure, of course. Now, somebody said that they sound the same to him. Like for example, here, if you said, if the question says if they give you this kind of chart to find the mean, of course you know that you're gonna get a midpoint. Watch the past videos on that. If you say find the mean, of course the formula for the mean, I have it. You look for the formula for the mean here, and I have it all the way down. I got the formula for say, okay, right here. This is mean for ungroup data. Computing mean for ungroup data. This is the formula for mean. But for the one that is involved group data, this is the mean right here. So use the formula. You read the question. Look for the formula to use to answer it. Okay.
What that big old E thing means again? I forgot.
Hold on. Let me see what you mean. You're talking about this one here.
Yeah, what that big thing? I forgot.
It means the sum of.
Summer.
Yeah.
Okay.
I have it written here. So you can see right here. Means sum of frequency. Yeah. Okay. This sigma, they call it sigma, means sum of. Yep. All right, guys. Oh, there's somebody. Before we leave, Miss Green, are you here? Okay. Anyway, you guys, I wish you good luck on the test, and I'll see you next week. Okay.
Who name did you say?
Wait a minute. I had a question.
Finding
So
the
I was working on the homework in Alex, and I did everything else except for the last, I think 2 or 3 problems, which was the box plot. But I didn't know how to like navigate the box plot to like put my answers in.
So what? We did it today.
No, I'm talking about in Alex though. Like I saw what you did when you created the box plot from Excel. I understand that. But in Alex on the homework, there's a box plot there, but I don't know how to make the adjustments to put my answers on there.
You
And when
don't,
I
yeah.
watched the example, it didn't show me how to do it.
Well, usually you type the numbers in, the numbers you got for your
Answer.
answers, and it will draw the box plot for you.
Oh, it already did it. Okay, I knew it did in Excel. So, because I was trying to maneuver the box plot within Alex, but once I typed my numbers in, it already did it for me. Is what you're saying?
Yeah. You see,
Oh,
so long as you put the right number, you gotta put the right number, the right spot where the
yeah.
unless we tell you where to put the numbers, put it right, then it will draw it for you.
Okay, all right. Thank you.
You're welcome.
One quick question, Professor.
Mm-hmm.
Where is the study guide again?
Oh, it is on I have it in Canvas. Give me 1 minute. Let me pull it out. You go to the model where we are. I'm gonna close this Excel since we are done with it, so we can have enough room. Now, actually, this is it right here, but you're gonna find it from the Canvas. Give me 1 minute. I sometimes this thing just navigates away. Okay, good. I think
Wait, I think I found it. Is it saved as a doc?
it's on the models. Say it again.
Is it saved as a doc?
Can you? Yeah, as a document. Yes. Can you see?
Okay.
Can you see my screen here on the Canvas?
Yes.
I mean, again, yeah. So you can see right here. So if you click on it, and then you can download it and use the practice.
Okay. Thank you.
You're welcome. All right, guys. Once again, good luck. And I'll post the video of this class, and I'll see you next week.
Thank you.
You're welcome.
Thank you. Good night.
Good night. Yeah.
Thank you. Good night.
Good night.
I'm still crying on the inside, Professor. I ain't gonna lie.
Don't cry inside. I gave you a hint.
I know. I'm
Well,
gonna do it.
do the experiment, and then tell me what you found out.
Yes, sir.
But you gotta do the experiment. Don't tell me I didn't get it. But if you didn't do the experiment, you gotta do the experiment. That part that you don't understand, watch it, like like 3, 4, 5 times. Then as you watch it, you can be doing the same example as you watch it.
Okay.
So when you do like 3 or 4 times, it should register.
Yes, sir.
Mm-hmm.
Professor. But you
No
have
more crying. No more crying
your
inside.
weekend, okay?
No more crying inside, man.
Okay.
Okay, bye.
Yeah.